We have 74 days. In 74 days, our interstellar visitor will pass Jupiter, and NASA will get one chance to solve a mystery that's been building since July. The data that arrived yesterday makes that encounter more critical than anyone expected, because something is happening that our models say shouldn't be happening. Welcome back. January 1st, 2026. While most of the world was celebrating the new year, a team of astronomers published measurements that should not exist. 3I Atlas, our third confirmed visitor from beyond the solar system, is producing water, not a trickle, a torrent, 40 kilograms per second. That's 88 pounds every second, continuously. Picture a fire hose at full blast. That's the volume, except this fire hose is operating in the vacuum of space, 280 million kilometers from the sun, almost twice the distance between Earth and the sun. At that distance, water ice should be stable, frozen, inert. Our comets, the ones born in our solar system, barely show any activity that far out. They're dormant, waiting to get closer before the sun's heat can unlock their frozen cores. But 3I Atlas didn't get the memo. The instrument that caught this impossibility? NASA's SOHO spacecraft, the Solar and Heliospheric Observatory. Launched in 1995, the same year Windows 95 came out, for 3 decades, it's been sitting at a gravitational sweet spot, a million miles from Earth, watching the sun. SOHO wasn't looking for comets, but when 3I Atlas crossed its field of view, the spacecraft detected something unmistakable, a glow, a halo of ultraviolet light surrounding the comet, the signature of hydroxyl radicals, OH molecules dancing in space. You remember your chemistry from decades ago. H2O plus sunlight equals OH plus H, water molecules breaking apart, it's water's fingerprint. And it was blazing. Think about that fire hose again. Now imagine it's been running non-stop since mid-October. That's millions of kilograms of water vapor, from an object that's supposed to be frozen dead. So where is all this water coming from? Here's where it gets strange. The surface area of 3I Atlas's nucleus, the solid core at its center, is estimated at maybe 20 square kilometers. That's tiny, about the size of a small town. At 280 million kilometers from the sun, the sunlight hitting that surface is weak, very weak. Do the math. The energy hitting 3I Atlas shouldn't be enough to vaporize water at this rate, not from surface ice. The numbers don't work. So scientists propose something else. The comet isn't just melting surface ice, it's ejecting clouds of tiny ice-coated dust grains. Microscopic particles, each one covered in a frozen shell. Together, they have enormous surface area, thousands of times more than the nucleus itself. When these grains hit sunlight, even weak sunlight, they heat up fast. Small objects always do, and they release their ice, feeding the cloud of gas we're seeing. But this raises a new question. Why is 3I Atlas shedding these grains so aggressively? What's happening inside it? In 1986, when Halley's Comet returned, the Giotto probe flew through its coma and discovered jets. Specific vents on the surface shooting gas and dust into space. Not uniform outgassing, targeted eruptions. Is 3I Atlas doing the same thing? Are there active vents, regions where subsurface ice is exposed, or is something else entirely happening? We won't know until March 16th. Here's something to consider. If you were designing a mission to intercept 3I Atlas to fly through its coma like Giotto did with Halley, what would you want to measure? What instrument would you bring? Leave your thoughts below, because the next interstellar visitor might give us that chance. The water vapor isn't the only mystery. It's what's mixed with the water. The James Webb Space Telescope, our most powerful infrared eye, analyzed 3I Atlas's coma during its closest approach to the sun. The chemical inventory is fascinating. Carbon dioxide, carbon monoxide, water, cyanide compounds, organic molecules, everything you'd expect from a comet. But the ratios are off. In our solar system's comets, water dominates. It's typically 80% of the volatile content. Carbon dioxide and carbon monoxide are minor players, maybe 10–15% combined. 3I Atlas flips that script. Carbon dioxide is much more abundant than it should be. Water, while present, is a smaller fraction. The Webb data shows a comet that formed in a colder, carbon-richer environment than our solar system's comets. What does that tell us? It tells us the star system where 3I Atlas was born had different chemistry, different temperatures in its planet-forming disk, different abundances of elements. Think about what that means. 7 billion years ago, around a star we'll never identify, in a region of space we'll never visit, a cloud of gas and dust collapsed. Grains of ice formed, they stuck together. Over millions of years, they became a comet. And that comet remembers. Its chemistry is a time capsule, a message in a bottle from a place and time utterly alien to us. The ice vaporizing right now, tonight as we speak, froze when the universe was half its current age, when our sun hadn't formed yet, when Earth was still scattered atoms in a nebula. You're watching time travel, not metaphorical, actual preservation of ancient matter, revealed under our sun's light for the first time in cosmic history. 74 days from now, everything changes. March 16, 2026, 3I Atlas will pass within 53 million kilometers of Jupiter. That's close, not dangerously close, but close enough. NASA's Juno spacecraft, currently orbiting Jupiter, studying its atmosphere and magnetic field, will turn its instruments toward the comet. For 8 hours, Juno will track 3I Atlas with every sensor it has. Radio receivers will scan for emissions. Plasma instruments will measure how the comet interacts with Jupiter's massive magnetic field. Cameras will capture the closest images we'll ever get of this object. This matters because Jupiter changes things. Its gravity is immense. Its magnetic field extends millions of kilometers. When 3I Atlas passes through that environment, we'll see how an interstellar comet responds to forces it hasn't encountered in billions of years. Will the water production increase? Will new vents open? Will the trajectory shift measurably? More importantly, Juno will measure things we can't measure from Earth, low-frequency radio waves. You remember Voyager 1 and 2? They didn't just photograph Jupiter. They discovered things, volcanoes on Io, Jupiter's rings, complex magnetic fields that changed planetary science forever. One close encounter, years of discoveries. Juno's flyby of 3I Atlas could be that moment for interstellar objects. Right now, if you have a good telescope, you can see 3I Atlas, magnitude plus 15.6, in the constellation Leo, about 2.5 degrees north of Omicron Leonis. It's faint, fading. Every night, it moves a little farther from the sun, a little farther from Earth. By late January, it will pass near M44, the Beehive cluster. By March, Jupiter, and then it's gone, back to the darkness between stars. But here's what keeps astronomers awake at night. 3I Atlas is the third interstellar visitor we've confirmed, Oumuamua in 2017, 2I Borisov in 2019, now this, 3 in 8 years. That's not the real number, that's just the ones we caught. Statistical models suggest dozens, maybe hundreds of interstellar objects pass through our solar system every year. Too faint, too fast, too far from our telescopes to detect.
3I Atlas is special because we got lucky. It came close, it stayed bright long enough, we had the instruments in the right places.
Here's the question I want you to consider. What if one of those undetected visitors wasn't a comet? What if it was something else? A rocky asteroid, an ice shell around a liquid core, or something we don't even have a category for yet? How would we know? Write your thoughts below. The water production we're seeing, this impossible, physics-defying torrent from 280 million kilometers away, is telling us we don't understand interstellar objects as well as we thought. Every comet we've studied for centuries was born here, in our solar system, under our sun's rules. We built models, theories, predictions based on that. Then Oumuamua arrived and didn't fit, too elongated, accelerating without visible outgassing. We scrambled to explain it. 2I Borisov fit better. A normal comet from an abnormal origin, we relaxed. Now 3I Atlas. Water where water shouldn't be. Chemistry that's close but not quite right. Behavior we can measure but can't fully explain. In 74 days, Juno flies past. We'll get data, some questions will be answered, new questions will emerge. That's how discovery works. But remember this, for 7 billion years, 3I Atlas drifted in the cold and dark, unchanged, preserved, and then, in October 2025, it woke up. What we're watching is the end of that journey, the final performance of an ancient traveler, and it's putting on a show nobody predicted. Thank you for watching. Subscribe, because on March 16th, we'll be back with the Juno encounter, and if you want to see 3I Atlas yourself before it fades, I'll put finder charts in the description. Until next time.